So the big one that most people really care about, if you boil it down to it, is the accuracy improvements. The largest improvements we've been seeing are when you couple amino and sonar with data science. We were consistently getting over 85% of projections within 50 grams about a week out for small birds. As that timeline got closer, the numbers went up to consistently over 90% within 35 grams.
Welcome everyone, this is Accelerate. My name is Nikolai Shitihin. I have Jim Johnston with me and we have two guests today. We have Evan Sadlon and Daniel Gustavo. Hi Jim, how are you doing guys?
Hi Nick.
Hey Nick, how's it going?
Hello Nick.
Yeah, we're all good and let's get into our guest, Jim.
Yeah, let's do it. Let's introduce the guest, Nick. It's great to be back actually on doing a podcast, and we got two really cool guests with us today. We've got Evan Sadlon, who is with MTech. He's been with MTech for 6.5 years, and he's in charge of the whole data science setup, data science manager at MTech, and has a master's in computer science and artificial intelligence. So that's really a subject we want to get into a bit today. And then we've got Daniel. Daniel's based down in Brazil, who's our product manager for ProLine, which is another exciting product processing planning solution. Now, Daniel's been with the business for 7 years, but as importantly, prior to that is 10 years processing experience in the industry. And so we're looking forward to you guys, to the chat with you today. And we're going to talk a little bit about how we use data science within the poultry supply chain, particularly around the areas of broilers, weight accuracy, getting broilers to the right weight to the processing plant, and managing the birds and the carcasses through the plant. Really, it's quite important amount, financially very important area, something that Nick and I have touched on in previous episodes, a very important area to get right. And we'll talk a bit about how we utilize data science at MTech, maybe to help in two areas, two products, one amino, which is what we use on the farming side of the business for MTech. And that's where, we really want to understand a bit more about how we can use data science in amino for predicting and forecasting broiler performance, and also in logistics. And then we'll move to talk Daniel a bit about ProLine. And ProLine's an MTech solution, which is all about processing plant planning. So taking that live bird through carcass into stock keeping units or finished product really, and trying to meet your customers' full requirements in terms of order execution. So fun thing, big subject, Nick, today. So we're going to need to kind of manage the time and the questions, but let's get into it, I guess, eh?
Yeah, absolutely. And like you said, we discussed this multiple times already because it's very topical in the industry every day, because planning is something that is constantly changing. You always need to project, predict, plan, and replan. And like we said, technology is already here. It's not something that we'll get sometime in the future. It's already live now and utilized. So today we'll discuss how it is utilized and what it is actually giving to the customers.
Great stuff. So first question to Evan, I guess. Evan, how is data science actually used, and what does it bring to the whole broiler planning and the whole logistics of getting broilers to plant? I mean, how do you use data science compared to the kind of old methodology that a lot of companies have used for years?
Yeah, so the way we use machine learning and data science in broiler planning is kind of twofold here. The first approach is to do better predictions, and then the other one is better planning. So to elaborate on this a little bit, a lot of current approaches use heuristic methods, which means kind of a first in, first out approach to scheduling when you pick up your birds. And this is great if you're running a very simple operation that you know exactly what you need and you've placed perfectly. But once your placements start going awry, or if you try to introduce thinning, things quickly fall off the rails. And so when we move away from this rule-based approach, this heuristic approach, into a more data science AI approach, it allows, when things do go wrong, for you to recover, for you to know what to do faster and to give you sort of options that you might not have thought of before. Yeah, you might take a small hit on this choice early on, but it's because it'll give you a greater benefit later down the line. The other thing that we're really hoping to leverage here is addressing all of the silos. So each part of the poultry supply chain kind of exists and plans in its own world. And yeah, it'll give its answer to the other modules, but in its current implementation, they don't work together. It's more of a push and pull. So the other part of this design that we're looking to do is to address this and build a single unified system where the kill schedule can actually talk to ProLine, or ProLine can actually talk to live haul schedule and say, oh, well, if you did this for me instead, it would be a lot better for me. Can you do that? So data science and machine learning have limitless possibilities within just the broiler planning. I mean, this hasn't even gotten into breeder or the full stack. So it's really exciting stuff to start powering our projections and optimizations using these new technologies.
Yeah, that's pretty cool. And you mentioned better planning and better projections. So if we talk about this a little bit more, since it's a new technology and it's a completely different approach compared to heuristic models, what do you see in terms of actual improvements? Is it faster? Is it more accurate? What is the accuracy levels you're getting right now?
Yeah, so the big one that most people really care about, if you boil it down to it, is the accuracy improvements. The largest improvements we've been seeing are when you couple amino and sonar with data science. We were consistently getting over 85% of projections within 50 grams about a week out for small birds. As that timeline got closer, the numbers went up to consistently over 90% within 35 grams. However, for big birds, anything over about 3.25 kilos gets a little tricky. We've seen improvements with that going from about 120 gram error down to below 100 grams. However, this really heavily relies on the customer's data quality, quantity, and data points that they collect. So those numbers might vary a little bit. We've also done this stuff in breeders just to really resounding success. My favorite part about the amino ML approach, though, is the automated retraining. Basically, instead of you having to keep up with, breed curves or product curves or, feed consumption curves, the ML does that for you. If it detects that there's a really drastic season change or you started a different business practice from the last time it was trained, it automatically detects its predictions against what actually happens. And when those drift too far away from each other, a pipeline automatically gets triggered without you having to do anything. It'll send you an email saying, hey, it looks like your model might be out of date. We're retriggering a training for you. And so this way it stays up to date and learns from your most recent data and practices to make sure that it's always giving you the best predictions possible.
Well, that's pretty cool because we all know that all the planning is usually requires quite a lot of manual adjustments. You need to see what's going on with this flock, with that flock. Maybe this grow out is changed or something like that. So, and it's great, that the model will retrain itself. And I was also having like more of a broad question to this. What do you think is needed in order to this technology to get even better? Do we need more data? Do we need like a global database? Do we need more sensors? Or what else is needed to make it perfect?
So not just good data, not just more data, but clean data. That's really what we've been seeing is some of the data that we've gone through, up to 20% of it had at least a couple of data points that were bad. So mortality for the whole flock might have been greater than 20%, which can that happen? Yeah, but not consistently, or hopefully not consistently. The FCR being over 3 was like, ooh, is this actually real, or did someone like enter in a wrong number? Because protein has so much flexibility, it enabled people to do a lot of weird things where at the very end, all the numbers lined up. But if you looked on a flock by flock basis or a house by house or a pen by pen or processing by processing basis, things got really funky. And so trying to line everything up properly was a little difficult. But to make it even more accurate and more better. Yeah, more data, more sensors would be great. Clean data. I'll espouse that till the day I leave data science. Is clean data is so much better than just more data.
Gotcha. All right. Thanks, Evan.
No, that's great, Evan. I'm really excited to learn about the accuracy, that the data science can bring to broiler weights, because I know the challenge has always been getting the right weight to the plant at the right time. And why that's important is obviously help the processing plant optimize yield, because the birds are the right weight. The machines in the EV can be set to gain yield from that. And then also, to ensure that we manage giveaway in a processing plant. And so that getting broilers of the right weight more accurately, more often to the correct weight to the plant is critically important going forward. And it's a really exciting tool that you've just briefly elaborated on there. And